Alright, so let's go through this integration question. So find the equation of a curve which has a gradient of 3x squared minus 1 over x squared, right? And it passes through the point 2, 4. Okay, so first thing we must recognize is that this is an integration question. Because why? Because first we have the gradient is equal to this, right? So what do they mean by gradient in A maths? Gradient in A maths just means dy dx. So if we are given dy dx is equal to 3x squared minus 1 over x squared, right? They will ask us to find the equation of the curve. So equation of the curve is like y equal to something, right? So how do I go from dy dx into y equal to something? So definitely we must do the integration. So of course, when we do integration, if you look at this form, it's a bit hard to integrate. So what I will need to do, right, is actually to decompose it, meaning that you need to split out, right? So 3x squared over x squared minus 1 over x squared. So this will give you the first term right here is equal to 3. Then the second term is 1 over x squared. So this one is, then you just need to integrate term by term. Okay, so I integrate. So it's y equal to integrate of 3 minus 1 over x squared. Of course, the 1 over x squared, you can make it into pure indices, which is x negative 2. So this is x negative 2 dx. So this will give you, okay, so first term, right, is 3x. Then second term is x minus, okay, so negative 2 plus 1. So negative 2 plus 1 is negative 1, but you must remember to divide by the so-called the new power right here. Then you need to plus c. Okay, so you just need to simplify first. So 3x, right? So minus, and there's a minus here. You should simply just put plus, plus x negative 1 plus c. So the next thing to do is actually to find the value of the c, right? So how do I find value of c? That's where you need to look at this thing. So they say, oh, this curve passes through 2, 4. So I just need to sub in. So before you do the substitution, I make it nicer. So 3x plus 1 over x plus c. So okay, so I sub in first, 2, 4, right? Okay, so I sub in 4 here. Then the x I sub in 2. So okay, 4 is equal to 3 times 2, 6. Half plus c. So it's 4 equal to 6 and a half plus c. So c is equal to negative 2 and a half. So the value of c is negative 2 and a half. So the equation of the curve is 3x plus 1 over x minus 2 and a half. Done. So this one I hope there's no integration mistake or calculation mistake. Okay, because previously the last video I had a differentiation mistake, so that's why I took down the video. Okay, for part 2, state the value of approach by the gradient as x become very, very large. Okay, so let's go back to this thing. So, okay, let's code this thing. Okay, so 3 minus x1 x squared. So dy, so part 2. Okay, part 2, dy dx, right, is equal to 3 minus 1 x squared. So if you look at this, right, they say that x becomes super large. What happened? So just by looking at the second term, so when I say, oh, 1 over x squared, where x is very, very large, so this thing will become equal to so-called very, very small, which is roughly equal to 0. So I just estimate it's equal to 0. So this will equal to 3. So if you don't believe, you can actually sub in some number. So for example, like x equal to maybe 10,000. So 10,000. Or maybe 1 million. 1, 2, 3, 4, 5, 6. So when you sub in, you 1 over 1 million square, right? So this 1 over x square will actually tends to become very, very small. Or I just equate to 0. So that's why 3 minus 0 is just equal to 3. So that is how we solve this value. So the answer for part 2 is actually 3.